All right, guys, so what we're going to talk about here is actually one of the easiest topics that we talk about probably in this entire class, just because all we're really doing in these problems is we're actually looking at a symbol that allows us to know when we are supposed to take the antiderivative of something. Obviously, math people, they don't like writing down the words, take the antiderivative. It's just that's a lot of words. They didn't want to have to write that repeatedly, so they came up with a symbol that is called the indefinite integral. Now, the indefinite integral symbol looks like this. It kind of looks like a music note, or maybe a stretched S is possibly what you could call it. But anytime you see this symbol, what this symbol is telling you that you need to do is it's telling you that you need to take the antiderivative of whatever comes after it, okay? In fact, what you'll see, so the way you'll see it is you'll see this indefinite integral sign, then you'll see some sort of function in here. So there'll be a function written, and it'll have x in it. And the reason why you know it has x in it is because at the very end, notice this says d, and then it says x. Now that dx, all that's telling us is what the variable should be inside of whatever function it is that we're going to take the antiderivative of. So we're taking the antiderivative, we could say with respect to x. What we're doing there is we're just looking at the variable that exists, and it's saying, okay, take the antiderivative, and this part at the end is saying that has to be the letter of the variable that we're looking at in whatever function it is that we are trying to take the antiderivative of. One small thing that is true that when we look at antiderivatives, and it kind of comes with the territory anyway, so it's not that big of a deal, but one rule that we can use when we're looking at these indefinite integral signs is we can say, okay, if there is a constant number multiplying a function, what I can do is I can take just the constant number and I can multiply that to the outside. Like here you can see there's a 3 on the outside, then I've got x squared on the inside. And then I would just say, okay, now I'm going to take the antiderivative. In other words, it's like you can factor it out. It's not that you're really factoring it, but it's just a step that will actually help us a lot as we get a little bit further into the class and when we deal with these indefinite integral signs that we are going to have to use. Okay? So if I wanted to find the indefinite integral of this, okay, that's the indefinite integral of 2x plus 3, and then we say dx, although, again, the dx is not anything important other than it's saying that's what the letter has to be inside of it. All this is saying is find the antiderivative. Okay, so the antiderivative of 2x squared is 2x squared over 2. The antiderivative of 3 is 3x. Then we have to remember our plus c on the end. So I get x squared plus 3x plus c. And that is my answer. And I'm done. Honestly, the only thing, again, that we have to remember is that the dx, it's just there to tell you what the variable is inside of the function we're taking the antiderivative of. You don't do anything with it. You don't need to worry about it. It just tells us what that variable is. And we're all done. Notice this is exactly what we did before. The only difference now is that there's a symbol that tells us to take the antiderivative instead of writing out the words take the antiderivative of. Okay, so here are all of the different the indefinite integrals or the antiderivative rules that we have. If I want the antiderivative of x raised to any power, then it's just add 1 to the power, divide by the new power, and put c on the end. The antiderivative of e to the x is e to the x plus c. The antiderivative of 1 over x, and this is actually slightly a lie, and I don't want to go into too much why right now, but the antiderivative of 1 over x is not just ln of x, it's the ln of the absolute value of x plus c, and we'll talk about why another time. Don't worry about it too much, but I promise you that's what it is. The antiderivative of secant x tangent x is secant x plus c. The antiderivative of sine of x is negative cosine of x plus c. Secant squared is tangent of x plus c. Cosecant squared is negative cotangent of x plus c. Cosecant x cotangent x is negative cosecant x plus c. And cosine of x is sine of x plus c. Now again, those are the only antiderivatives, the only indefinite integral rules that we know. There are no other ones besides those that you even have to worry about because those are the only 9 that we have that we can use on a regular basis. Everything else that we do will be based off of these 9 in this class anyway, but know that those are the only ones that we have to know. And quite honestly, knowing that one, that one, that one, and that one, so those 5 that I have marked there, will probably get you through the AP test without any worries. The other ones you probably should know, but you'd probably be just fine on the AP test not knowing them. So if I had something like this, 3t squared plus t to the 4th minus cosine of t, and I want to take the antiderivative, hopefully you can see that it would be t to the 3rd plus t to the 5th divided by 5 minus the sine of t, and then I got to put my plus c on the end. Notice they were t's this time instead of x's, but everything still worked exactly the same because I've got a dt there, which means that's going to be the variable inside of the problem. So looking at that, t to the 3rd plus t to the 5th over 5 minus sine of t plus c is the antiderivative for this particular function. Okay? Now, that is all. There's nothing special going on with these functions. There's nothing that you need to know that's above and beyond what we've done before. Just know that that is what we did in this particular problem. And when I see this antiderivative sign, it is telling me you've got to take the antiderivative. They just didn't want to have to write the words. Hopefully that makes sense. If you have any questions, please let me know.